All right, let's dive in. Today, we're exploring quantum computing. Get ready, it's gonna get weird.
Yeah, it's definitely a brain twister. We're talking about using the bizarre rules of quantum mechanics to compute, like
Yes.
completely different from your laptop.
And at the center of it all is Google's new baby, the Willow chip. It's crazy to think something the size of like a tiny chocolate mint is gonna shake up the entire tech world.
It's all about the speed. Willow's working at a scale that makes normal computers look like they're standing still.
Hmm.
We're talking septillions of years faster. Septillions.
Septillions. Wow. That's like before time even began. I am so ready to hear how the speed translates into, things that actually matter.
Well, imagine drug development. What if you could perfectly simulate how molecules work at the tiniest level? Test thousands of drug possibilities all at once.
So instead of years in the lab, it's more like days or weeks.
You got it. It would totally change how we find new cures and treatments.
Yeah.
We could have medical breakthroughs at a pace we've never seen before.
That's mind-blowing. And I read that they're even looking at Willow for nuclear fusion research. That seems like a huge jump.
It might seem like it, but it's all about that raw computing power. Fusion involves these insanely complex calculations. To really understand how particles interact at crazy high energy levels, we need serious horsepower. And Willow could be the key.
So it's like having a superpowered microscope that can see and understand the tiniest parts of the universe and then, use that to build a star on Earth. Okay, my mind is officially blown.
We're just getting started. Willow has so much potential beyond medicine and energy. Think about artificial intelligence.
I mean, AI is already changing everything so fast. How could quantum computing even make it more powerful?
Imagine algorithms that learn and adapt exponentially faster. They could solve problems we haven't even thought of yet. AI that could actually help us tackle climate change, design personalized education, even compose music that rivals the greatest composers.
Whoa, that's a lot to process. But with all this talk of quantum leaps and insane speeds, there's got to be some challenges too, right?
You're absolutely right. Building and controlling a quantum computer is one of the most difficult things we've ever attempted. And one of the biggest hurdles is something called error correction.
Error correction, what does that even mean?
So qubits, the basic unit of a quantum computer, are incredibly sensitive. Like the slightest interference, even a single photon, can mess everything up and cause errors.
So it's like trying to balance a spinning top on a bumpy road. The slightest bump and everything goes off course.
Perfect analogy. And that's where error correction comes in. We're talking about creating these sophisticated systems to protect those qubits, to keep the calculations accurate. It's like having a team of tiny mechanics constantly monitoring and adjusting those qubits, making sure they're spinning perfectly.
So where does Willow fit into all of this? How good is it at this whole error correction thing?
That's one of the most exciting things about Willow, actually. Google says it's a major leap forward in error correction, and independent experts are backing them up. They've managed to achieve a level of control and stability that's never been seen before in a quantum computer this size.
So even though it's early days, Willow is already showing signs of being a real game changer. But what about those speed tests they've been running? Are they solving actual problems or are they just showing off?
Good question. It's important to remember that those speed tests, while incredibly impressive, were designed to highlight Willow's raw capabilities. They weren't focused on real-world problems yet. Think of it like a car company showing off a brand new engine on a test track. It's about potential, not everyday driving.
Okay, I get it. So while Willow can achieve mind-blowing speeds, it's still got a way to go before it's curing diseases or cracking fusion. But it definitely feels like we're on the edge of something huge.
We are. That's why quantum computing is so fascinating. We're not just talking about faster computers, but a whole new way of thinking about computation. It's like going from an abacus to a supercomputer, but even bigger than that.
I'm starting to see why there's so much buzz. It's not just faster computers, it's about possibilities we haven't even imagined yet.
Exactly. And those possibilities are only going to grow as this technology keeps evolving. We're at the very beginning of the quantum computing era. It's anyone's guess what incredible breakthroughs are coming next.
So we've got this crazy fast Willow chip, and it has the potential to totally change medicine, energy, so many things. But where does this all fit into the bigger picture? Is Google the only one playing in the quantum sandbox?
Oh, not even close. This is a global race, like the space race, but for the quantum realm. We've got tech giants like Microsoft, universities like Harvard, and companies like Quantinuum, all competing to build the future of computing.
It's not just about building the fastest computer anymore. It's about who can use it to actually solve real-world problems first.
Exactly. And that's where it gets really interesting. We talk about drug development, fusion, AI, but the potential of quantum computing is way bigger than that. Think about material science. We could engineer materials that we can only dream of right now.
Like self-healing materials. Or superconductors that can, like, move electricity with no loss. That sounds straight out of science fiction.
Doesn't it? But that's the power of quantum computing. It can
Yeah.
turn sci-fi into reality. And don't forget about cryptography.
Right, we talked about that a little bit. Quantum computers could break the codes that protect, like, all our online data. That's a pretty big deal, right?
It's definitely a risk that security experts are taking very seriously. But the good news is they're already working on it. There's a whole field called post-quantum cryptography, figuring out new ways to protect data that even quantum computers can't crack.
So it's like a cat and mouse game. The code breakers versus the code makers.
Yeah, kind of, but it's a game we have to win. Our digital world depends on it. And remember how we talked about error correction being a huge challenge? Well, for cryptography, it's even more crucial.
Oh, why is that?
Because even a tiny error in a calculation could make a code completely vulnerable. It's like having a lock with a million tiny tumblers, and if just one is off, the whole thing breaks.
Okay, yeah, I see that. So we have this global race to build these quantum computers, another race to protect our data from them. And on top of that, we have to worry about these super sensitive qubits making mistakes. It sounds a little chaotic.
It can be, definitely. But it's also super exciting. We're at the forefront of a tech revolution, figuring out what's possible. And there's a lot of optimism, a lot of collaboration, even with all the challenges.
I can hear that excitement. But let's get real for a second. When are we going to actually see quantum computing changing our everyday lives? Are we talking years, decades?
That's the million-dollar question. It's tough to say for sure, but a lot of experts think we're on the verge of a major breakthrough. There's this guy, Dr. Peter Leak from Oxford. He's a leading researcher, and he's predicting big things in the next 5 years.
5 years? That's a lot sooner than I thought. What's making him so optimistic?
He thinks all the recent progress in error correction, plus all the money being poured into research, it's all going to lead to quantum computers getting way more powerful and reliable really fast. And as that happens, we'll start seeing them used for practical stuff.
So in just a few years, we could see quantum computers developing new drugs, making crazy new materials, even cracking the codes that protect our most important information.
It's definitely possible. Sure, there are still challenges, but things are moving incredibly fast.
This is starting to feel like we're living in a sci-fi movie. These incredibly powerful computers based on quantum mechanics, a global race to harness them, the potential to change everything. It's almost too much to take in.
I know, right?
Yeah.
It's a lot. But that's what makes it so cool. It's pushing the boundaries of what we know and what we think is possible. As we explore the quantum realm, who knows what we'll find?
You've definitely piqued my interest. But before we get too carried away, let's talk practicality for a minute. Building one of these quantum computers, what does that even look like?
Well, you definitely need a team of the best scientists and engineers in the world. People pushing the limits of physics, material science, all of it.
So, not something I can just build in my basement then.
Probably not. Quantum computers are super complex. They need really specialized equipment and environments. We're talking colder than outer space, lasers manipulating individual atoms, mind-bending algorithms.
It sounds like building a quantum computer is as much art as it is science.
You could say that. It takes incredible technical skill, creative problem solving, and a willingness to go beyond what we think we know.
And I'm guessing the cost is not cheap.
Yeah, building and running these machines costs a fortune. We're talking millions, even billions of dollars.
So, access is pretty limited right now.
For now, it's mostly big tech companies, research labs, and governments. But that's changing. As the technology gets better and cheaper, we'll see more organizations getting access.
That's good to hear, because the goal is to make this technology available to everyone, right? So we can all benefit.
Definitely. That's why open collaboration and sharing knowledge is so important in the quantum world. The more people who can access this tech, the more we'll all benefit.
I like that. It's not about keeping secrets, it's about working together to build a better future. But we can't forget that with great power comes great responsibility, right? We need to think about the risks and the ethics of all of this.
Absolutely. We talked about security and encryption, but there are other concerns too, like bias in algorithms, making sure this technology is used for good and not for harm.
Yeah, lots to consider. It feels like we're navigating a whole new world with quantum computing. But one thing's for sure, we're on an incredible journey, and the possibilities are endless.
It is an exciting time to be a part of it. Who knows, maybe we'll look back on this as the start of a whole new quantum age.
I feel like we've just dipped our toes into the quantum ocean, and I'm already overwhelmed.
It's a lot to take in, for sure.
Yeah.
But hopefully you've got a sense of how big of a deal this is. Quantum computing, it's not just an upgrade. It's a whole different way of thinking about computers.
It's like we're not just talking about faster computers, we're talking about harnessing the power of the quantum realm, which, by the way, is so much cooler. So what's the one thing you really want our listener to walk away with today?
I think it's the potential. The sheer, almost limitless potential of quantum computing. We talked about drug discovery, new materials, AI, breaking codes, even fusion power. And honestly, that's barely scratching the surface.
It really does feel like we're standing on the edge of this vast, uncharted territory, like we've only glimpsed a tiny fraction of what's possible.
Exactly. And the most exciting part, this field is moving so fast. Things that seem impossible today might be everyday reality in a few years.
It's almost hard to imagine, what kind of world are we going to be living in 10, 20, even 50 years from now, thanks to quantum computing? What are you most excited about?
For me, it's the potential to solve some of our biggest problems. Climate change, hunger, disease. These are all challenges that quantum computing could help us tackle.
It does give you hope, right? Even with all the problems we face, we're developing the tools to maybe actually solve them.
Definitely. And that's why I think it's so important for everyone to be aware of this, even if you're not a scientist. Quantum computing is going to affect all of us, so the more we know, the better prepared we'll be for this crazy future.
So, to our listener, keep learning, stay curious, and maybe get a little excited about this quantum future we're all heading into. Who knows what amazing things we'll discover in the world of the super small.
Thanks for joining us on this quantum deep dive. Keep exploring.
Here at MindMeld XL, we believe our best future will rely on a fusion of man and machine. Subscribe to the channel to follow our journey.